Oh, 2 and 45. 2 minus 1. Is that what you plugged it in? No, yeah, I did that originally, and then whatever. 2x minus 2. I know, but twice in would be 22. See the difference of 2 and twice in here. But that's
word this way.
Is it in order?
Yeah.
Is it in
What's
order
the
for sure?
difference of 7 and 4?
I got it right. I'm 1. Right.
What's the difference of 1 and 7?
Like, is it both?
I understand because I don't remember. But I think it goes.
So you think that we would have to word it with wording the difference one? 2 times the number and 2. You have to say that.
Yes. Yes. That's right.
Exactly. It's one of those where it's all in. How do you define the wording of it? Yeah. So how do you allow? I agree with you.
Everything's done different, so we've always done.
In that one.
Yeah, we did I understand this. That one's a little gray.
Yeah.
On that one. So.
No, I agree. Thanks.
Yep. Here's some answers as well. It'll be on Canvas if you need to go back to that one. All right, you do have that answer key in front of you. If it makes sense, okay, that's important. That when you look at it and you make corrections, that makes sense. Anything that needs further clarification, I do want to say one thing, which was a good question on, let's see here, number 43. 43. And that is square root of y plus 6 equals y. And when we're done, you get y equals 3, and you get y equals negative 2. I'm not going to go through that work. All right, now, why doesn't negative 2 work? Here's what you got to understand is when you're doing this, we're plugging in the square root of negative 2 plus 6 equals negative 2, and that's the square root of 4. When you are given a problem with the square root in it, that is what we call the principal square root, and it's understood to be the positive square root. Okay? So the square root of 4, we don't label as plus or minus 2. That is just 2. And so 2 equals negative 2. All right, for that. If you got y equals, or y squared equals 16, and we introduce the square root, okay, now it's going to be plus or minus because you're squaring that y. And negative 4 squared is the same as 4 squared. So you got to get that. And in this case here, that's just a y. In that case, it's not being squared. So we just take the principal square root of 4, which is 2. And that does not equal negative 2, so you have to eliminate that answer. That answer is extraneous, okay, for that. So it's a little bit of gray area, technical area, but that still you have to toss that answer out. Anything that needs a little bit more clarification, I suppose what you got on your answer key. Right. Make sure you fix them, okay, so you can come back. You understand what's going on if you look at it again. All right, section 1.6, I got guided notes. It makes it easier with dealing with the inequalities, graph, and all that good stuff. So that's in front of you. I'll come by and collect these answer keys in a little bit when I get a chance. Less than, greater than, less than or equal to, greater than or equal to. We're mostly going to focus on compound inequalities. You should be good with just straight inequalities. And so main thing here, or not the main thing, but a thing is interval notation. Okay, and that's how all your answers are going to be expected to be written. Majority of your answers will be written in interval notation when you're dealing with more than multiple solutions. So x is greater than or equal to negative 3. You can either put a solid dot to the right, or sometimes you will see a bracket as opposed to a parentheses. Either one would be fine. Now, in interval notation, okay, x such that little pitchfork there, it's an epsilon, Greek letter epsilon, it means such that. And that means it will be, that shouldn't be solid. What am I doing? I'm sorry. That is not equal to. So hopefully you guys did not fill it in. It should be an open dot, and that should be a parenthesis. Sorry about that. And now x such that it exists in the interval from -3 to infinity. So all those answers. Okay. So it's just a little bit notation-wise. All right, I want the final graph. I want the final interval notation. So we say -4 is less than or equal to x, less than 5. So we're going to go over and we're going to graph it. It can include -4. So that's going to be a solid dot. It will not include 5. It will be a hollow dot. And since it has to be bigger than -4 and less than 5, has to be anything in between. Now, you won't always see the notation x such that. Sometimes we'll put it down there. The other way we can just do that is just -4 with a bracket to 5 with a parenthesis. That just means all the solutions from -4 to 5. Okay. All right, x is less than or equal to 3, or x is less than -5. X is less than or equal to 3, or x is less than 5. Sometimes the two inequalities will merge into one final answer. You got to make sure you have the final answer graphed for that. So I'm going to do that. I wouldn't put it down on your number line yet. So I'm going to do a little bit of work above it. So I want you to think about this. Less than or equal to 3. Solid dot at 3 to the left. Less than -5. Open dot, graph it to the left. We agree? All right, I can combine that to one final graph. What will that look like? I don't want to have two of them to interpret. So what will represent all the solutions? All right, I don't know if I'm making any sense here. Austin?
It'll be all less than 5, -5.
All less than 5. So I'm going to disagree. Here's why, because it's the word or. Because any answer, if it works for one of them, it has to work for the other. So the number 1 is 1 less than 3. Yeah, so it has to be my answer. Doesn't have to work for both of them, only has to work for one of them. So if it's the word or, that's when you kind of merge the two together. Okay, you put the two together. So what's that final graph going to look like when you merge those two together? All right, Madison, what do you think?
I don't know.
You don't know? Why don't I just tell you what it looks like? How about that? So it goes from 3, because this is going to cross over, where this graph is. And so it's going to start at 3, and it's going to go all the way to the left, and it will include that -5. Don't put it like an open dot there, because -5 is less than 3, so it's in the solution. So in interval notation, the answer will be x such that, and it's going to start, and always in interval notation, you got to put the smaller number on the left, the bigger number on the right, just like you're thinking of a number line. Okay, so it would go from -infinity to 3, but it includes 3. Anytime you got infinity, you can't use a bracket, because infinity is not a point. Infinity is not a spot. You got to use a parenthesis because it keeps going on forever. All right, so that's going to go from -infinity to 3. So any number will solve, since it says or, one or the other. Right? The only ones that won't, like 7. 7 is not less than 3. 7 is not less than -5. It can't be an answer. All right. What if it says and? X is greater than or equal to -4, and x is less than 2. If it says the word and, it's got to work for both of them. You got to work for the first. Any number that works as a final solution has to work for the first one and the second one. All right, the first one again. I'm going to do a couple above my number line just to kind of get a picture, and then put the final answer on the number line. So greater than or equal to -4, solid dot to the right. I want all the numbers bigger than. Less than 2, hollow dot to the left. It has to work for both of them. What works for both of them is where they overlap. Those are the only answers that work for both of them. Okay. Well, where does it overlap from? It overlaps from -4 to +2. It does not include 2 because 2 doesn't work for the second one. And you will shade everything in between. Interval notation. X exists in the interval. Bracket at -4, parenthesis at 2. Okay? Bracket at -4, parenthesis at 2. All right. I want you to put that one down. Think about it. If you know what it is, graph the final answer. If you're not sure, then just wait. You got x is greater than or equal to -3 and x is greater than 4. So when I'm looking at this one, I got greater than or equal to -3, solid dot. Shade to the right. Greater than 4, open dot to the right. Since it's the word and, it has to work for both of them. That means it has to occur where both of those lines are. So it's going to start at 4, final answer. We'll start at 4, hollow dot, graph to the right, make sure you got an arrow on it. So it's going to be x exists in the interval from 4 to infinity. All of these you have to be able to put down the interval notation. Okay, all of them have to put down interval notation. Okay. All right, so that's just dealing with compound inequalities, whether it has the word and or, whether you got greater than, less than, greater than or equal to, less than or equal to. So it's just looking at those and making sure we can interpret the final graph. All right, recall, when multiplying or dividing an inequality by a negative number, flip the inequality sign. So that's that next statement there. Okay, that's something you've had for a while. Sometimes it just slips your mind. But anytime you multiply or both divide, okay, by a negative number, flip that inequality sign. Make it go the opposite way. So key thing here, we're going to solve all these inequalities, write all solutions in interval notation. Okay, so in the end, so you'll have like your x is greater than 2, write in interval notation as well. All right, so the first one is a linear inequality. We just got to get x by itself, distribute the 2. 4x plus 9 is greater than 2x plus 12 plus 1. And that gives me 2x plus 13. I'm going to subtract 2x, and then I get 2x plus 9 greater than 13, subtract 9. 2x is greater than 4, x is greater than 2. Interval notation, that's going to be x exists in the interval from 2 to infinity. Okay, for that one. The graphing part, you can use the graphing part to help with the final answer if you need it. Now here, I know you don't need to, but you might in a couple down the road here. But make sure you list it in interval notation. All right, second one there. 7 minus 2x is greater than or equal to -3. Now I'm kind of forcing the issue here. Subtract 7. Subtract 7. I get negative 2x is greater than or equal to negative 10. You have to divide by negative here. And then x is less than or equal to positive 5. And so that means x exists in the interval from negative infinity to 5. You got to put a bracket on that 5. So I should be able to plug in anything. 0 is in that interval. If I plug in 0, you get 7 is greater than or equal to negative 3. That works. Something out of the interval would be, say, 10. 2 times 10 is 20. 7 minus 20 is negative 13. That is not bigger than negative 3. So you can always just test something real quick. Okay. 3 times the quantity x plus 2 plus 2x greater than or equal to 5x plus 18. Distributed 3, I get 3x plus 6 plus 2x is greater than or equal to 5x plus 18. 3x plus 2x, 5x plus 6, greater than or equal to 5x plus 18. I'm a big fan of moving the x first because it just leads to fewer mistakes. Subtract 5x. All right, what happens there? That's 0. I'm left with 6 is greater than or equal to 18. Okay, this is a special case. It's either going to be no solution, it's going to be all real numbers. Is 6 bigger than 18? No. So that means there's no solution. Nothing would ever work. All right. If you get an answer in the end and it says 18 is greater than or equal to 6, that means x is all real numbers, which would be in interval notation, negative infinity to infinity. Okay, you can do it like that, all real numbers. If you get a false statement, no solution. True statement, everything will work. That goes from negative infinity to infinity. All right. Throw some compound inequalities in there. Flip it over to the back. Over to the back. All right. You're not required to do this. I like it in this format, but you can rewrite this using the word and or. Okay. And I want to at least show you what that looks like. Okay. I'm going to leave it like this when I solve it, but to rewrite this, I can put 4x minus 2 is greater than negative 6, and 4x minus 2 is less than or equal to 4. Okay, that can split apart. Hopefully that makes sense. So 4x minus 2 is greater than negative 6, because how it's written. And at the same time, 4x minus 2 has to be less than or equal to 4. Now, I prefer to keep it in this format. I just want to make sure you understand that that's the same. To solve it when it's like this, you add 2 to the middle, the right, and the left. And that'll give us negative 4 is less than 4x is less than or equal to 6. And now we just got to get the x by itself in the middle there. And that's going to be divide by 4. Divide by 4. I get negative 1 is less than x is less than or equal to 3/2. Interval notation. X exists in the interval, parentheses negative 1 to 3/2. Now, like I said, I would always do it that way. But if you do it this way, you add 2, you get 4x is greater than negative 4, you get x is greater than negative 1, which is basically that piece right there. X is bigger than negative 1. If I add 2 here, I get 4x is less than or equal to 6. X is less than or equal to 3/2. and I got the word and. So we go back to that first page. I got two things, two inequalities with the word and. They're going to overlap and give me that. But you can just leave it like this and solve it. Now they'll make it a little bit more complicated. Just want to make sure you see something like this. 12 is less than or equal to 4x minus 2 over 3 is less than 30. I would get rid of the fraction. Multiply everything by 3. Okay, I would encourage that. 3, 3, 3. That gives me 36 is less than or equal to, those cancel, and you just get 4x minus 2 less than 90. I'm going to add 2. I get 38 less than or equal to 4x less than 92. Divide by 4. And let's see, what do we end up with? And for here, I don't mind a decimal. What is it, 9.5? 9.5 is less than or equal to x. Is less than, I believe that is 23. Hopefully we're good there. Interval notation. X exists in that interval. It's going to include 9.5, so you need a bracket. Comma 23. It does not include 23, so you got parentheses that. Okay, less than or equal to, bracket means it includes a point. Less than or greater than, parentheses. Doesn't include that point. All right, these are compound inequalities with the word and. Like you could rewrite them like this. You cannot write the word or. If it has the word or, you cannot combine it into one one problem. You got to keep it as two different problems. So the only way you can do an or is if you got one statement here or the other statement. All right, so copy that one down for number 3. Go ahead and solve it. Solve the left-hand side, solve the right-hand side. And let's see here. I get 3x plus 3 minus 2 is less than or equal to 4. That gives me 3x plus 1 is less than or equal to 4. Subtract 1. 3x is less than or equal to, whoops, hold on there. That should still be a 4. Less than 3. I get x is less than or equal to 1. Distribute to 3. 3 minus 3x plus 13 greater than 4. Negative 3x plus 16 is greater than 4. Subtract 16. I get negative 3x is greater than negative 12. Divide by negative 3. Flip that sign, so I get x is less than 4. So or. Now all you are required at this point is to give me the final interval notation. If you need to do a number line to help you, fine. Now, and it doesn't have to be anything fancy. So less than or equal to 1. Well, I need a 1 and a 4, so I just put a 1 and a 4 here. Less than or equal to 1, solid dot there to the left. Less than 4, open dot to the left. All right. So in the end, all right, what's that going to be? Tim, what do you think the final interval notation?
In parentheses 4 and then negative infinity, or other way around.
Okay, yeah, what has to go first?
The infinity.
Yep, so it says we got to go left to right, so you go negative infinity to 4, and it doesn't include the 4 because we had an open, it was just less. All right, I agree. So negative infinity to 4. Now, again, keep throwing some fractions at you. Keep working on through those. I think it's helpful. Last one here for the lesson And if I didn't space them out far enough, obviously you can just move the number 4 down if you need to. 5 minus 3x divided by 3 is greater than or equal to 1/6. Or x minus 1 over 3 is less than or equal to 1. All right, on this left-hand side, I would multiply by the common denominator. Okay, what will 3 and 6 both go into? They'll both go into 6. It's got to be the same number. You can't multiply this one by 3 and that one by 6. It's got to be the same number. 3 goes into here twice. So this becomes 2 times 5 minus 3x is greater than or equal to 1. I'm just going to solve this one here. Distribute, I get 10 minus 6x greater than or equal to 1. Subtract 10. Looks like I get negative 6x is greater than or equal to negative 9. Divide by negative 6. I divide it by a negative, flip my sign. X is less than or equal to, and that will reduce to positive 3/2 or 1.5. Okay. On the other side, multiply each thing by 3. This is a totally different problem. And so that'll cancel. Your x minus 1 is less than or equal to 3. Add 1. It looks like I get x is less than or equal to 4. Want to add that one. So I get x is less than or equal to 3/2. X is less than or equal to 4. It is or. Okay. So again, if you think about it, 3/2 and 4, both solid dots, both going to the left. It's going to be, we want to go from 4, negative infinity to 4. So the final answer is x exists from negative infinity to positive 4, inclusive. Includes that 4 for that one. All right, interval notation is important. Make sure you double check that. All right, this is the homework from 1/6. So test next Thursday. I gave you that review. Like I said, just if you want to get ahead, review a few things.